Okay, hello everyone. Right. So we continue. I think we stop if you see the video, okay, in my YouTube, right? So I think I stop until here. Okay, so I will continue with the diode, okay, and after that half rectification, okay, full wave rectification, okay. Then after that we will go to the transistor, okay, if we have time to tonight lah. If not, we continue tomorrow. Okay. All right. So just a quick review, right? Okay, just a quick review. Okay, so wait. Okay, so we already know, right? We already know that actually what there are three types, right? Semiconductor, conductor, another one is the insulator, right? So what is the difference? Okay, what's the difference? So for conductor, you already know the conductor they can the charge can flow right through the conductor. Okay, but for the insulator, right, the charge cannot flow through it. Okay, but then semiconductor, all right, so semiconductor means the charge can flow, okay, but not as good as the conductor. Okay, so that is a semiconductor. So how you want to produce the semiconductor, right? How you want to produce the semiconductor? Okay, so there are three atoms, right? Sorry, there are two atoms that use. Okay, someone. uh, Okay, there are three atoms. Okay, that two atoms that use, okay, for to produce the semiconductor. The first one is a silicon. Okay, usually we use a silicon, okay, or germanium, right? So we use silicon and germanium, and the process, right? Okay, so the process to increase the conductivity, right? The process to increase the conductivity, okay, for the semiconductor, for the germanium and germanium and silicon, okay, the process that we want to increase the conductivity of the silicon and germanium, we call it the process of doping. Okay, we call it the process of doping. Okay, what is actually a doping? Okay, so mean you put another atom, okay, inside of it, you put another substance, okay, so it can increase the conductivity of the conductor. All right. Okay. So there are two types of semiconductor. Okay, there are two types of semiconductor. All right. So this one doping process. So there are two types. The first one is this one I already explained, right? This is a quick review. Okay, so N-type semiconductor. So when they talk about the N-type means it's just like means the negative or the electron, okay, is much higher than the proton there. Okay, if the P-type means, right, the whole, okay, the whole actually represent by the positive charge, right? So it has more holes than the negative charge. Okay, so example, right? Example. So there are two types semiconductor, P-type and N-type. Okay, so for example, for the N-type, right? So for the N-type semiconductor, okay, silicon or germanium is actually in the group 4, right? So mean the electrovalence is 4. Okay, so you have to dope, okay, you have to dope it with the pentavalent atom. So 4 plus 5, you got 9, right? So means there is an extra of electron there. Okay, so that's why it says drop poor semiconductor atom with pentavalent atom to produce an abundance of electrons in the semiconductor. So mean there are more free electron. Okay, there are more free electron here. Okay, but how about the p-type semiconductor? Okay, you dope the poor semiconductor, silicon or germanium, okay, with the trivalent atom. So what does it mean by trivalent atom? Means it has 3 electrovalence. So 4 is actually the electrovalence for silicon or germanium. So 4 plus 3, you got 7, right? And you already know for the extravalence, they must have 8, right? So mean there is 1 is not enough. Okay. and that one will become hole. Okay, this hole is a positive charge. Okay, so the dope poor semiconductor with trivalent atom to produce an abundance of holes in the semiconductor. Okay, so means for the N-type they have more electron than holes. For P-type they have more holes than electrons. Okay, right. So we just compare here, okay? We just compare here, right? So poor semiconductor for the N-type is silicon germanium. It's just same. It's come from the group 4, right? From the periodic table. Okay, and the dopant material, all right. This one is the important one. You have to know, okay, what material, okay, that need to be used, okay, to produce the N-type conductor and P-type. So phosphorus, arsenic, and antimony. Okay, for the P-type, we have a boron, aluminium, and also gallium. Okay, so this is the dopant material. Okay, so if you want to increase the conductivity of silicon and germanium, okay, and you want to produce the N-type semiconductor, you have to dope it with the phosphorus. So let's say example silicon plus phosphorus or germanium plus antimony. So that will produce the N-type semiconductor. But for the P-type, if you dope the silicon with the boron, okay, you will get P-type semiconductor, or germanium with aluminium, you can get P-type of conductor. So this one you need to memorize. Okay, function of the dopant material. Okay, what is the function of the dopant material? Okay, so N-type, right? N-type means they have a negative, right? A negative means they got free electron there. Okay, so when it's a negative means the dopant material is pentavalent, right? 4 plus 5, 9, right? So the dopant material is the pentavalent. So it donate, right? It donate, okay, it donate the electrons to the N-type. To the semiconductor produce N-type conductor. Okay, but for the P-type, okay, for the P-type, they only receive, right? The dopant material only receive, okay, only receive the electrons from the semiconductor. Okay, valence electron. So this one I already explained just now. Majority charge carrier. Okay, cis N-type, of course, you got many free electrons. So the majority is the electron. If the P-type is a hole, don't say positive, okay? You say holes, okay? Right, so holes we know that it's a positive charge because you already know that electron, if they don't have enough, enough electron in one pentavalence, right, the atom will be a positive charge, right? Okay, and the minority for the electron is the holes, and then for the P-type is the electron. Okay, now, so what is the function, right? What is the function we make some N-type semiconductor, P-type semiconductor? What is the function actually? So we need that one, P-type and N-type, to produce two electrical I think the electrical that part, okay, the electrical part that we call it as a diode and also a transistor. So both of it, they use a semiconductor P or NN. All right, okay, so this is called diode. Okay, remember you need to know the charge, which one is a positive, which one is a negative. So this part is a negative, this part is a positive. Okay, oh sorry. Okay, so why you need to know? Because you need to know later whether it's a reverse bias or the forward bias. Okay, then you can know whether the lamp or any the electrical appliance, right, flows through it. Okay, so it can be switched on or not. Okay, the bulb will light on or not. Okay, so this is the diode. So the diode is actually consists of semiconductor. Okay, which one is a semiconductor type? N-type and P-type. So N-type, of course, this one is P-type. So they just combine two semiconductor to produce a electrical part. Okay, so this is a diode. Yeah, just combine the positive and the negative, the P-type and also the N-type. Okay, now actually this one I already explained to you for the forward bias and the reverse bias. Okay, so let's see for this one, right? So remember, you have to put, right, the charge for the diode. Please put the charge of the diode. Why? So if you don't put, then we don't know whether it will be forward bias or reverse bias. Okay. So we already know that the current flows from the positive to the negative. Okay. So positive to positive, right? So positive to positive, okay, is will be forward bias. So forward bias means the current can flows through the circuit and it will be complete. Okay. Remember, in order for the bulb to light on, the current must be complete. Must come from the positive to the negative until the end of it. Okay. So let's say lah, sometimes they put let's say here, right? Yeah, okay, let's say they put the bulb here. Okay, they put the bulb here. Okay, and they put the diode here. Okay, I know there's some of you, okay, they said because right, this one means the bulb already passed, right? The current already passed through the bulb, right? So me it can light up. No. In order to light up, it has to be one complete circle. One complete cycle means anything positive to the negative. Okay, so back to the question. So this one positive, negative. So positive meet with the positive will become forward bias. So forward bias, the current will flow. Okay, so the current can flows until the negative terminal. Then the bulb will light up. Okay, so the negative, let's say for this one, okay, the positive go here, then it go to the negative. Okay, so different charge, right? Okay, actually there's a story what happened here later. Okay, I will tell. So positive to the negative. So that one is a reverse bias. So when it says about the reverse bias, okay, the current cannot flow. Okay, so the bulb will not light up. Okay, and this is the symbol of diode, right? So this is symbol of diode. So let's say they ask you to draw the diode, all right, to make the bulb light on. So you need to know lah which one is the positive and the negative terminal of the battery. Okay, and then you have to know whether how to connect it with the bulb. With the diode. Positive have to be with the positive, right? So you need to know which side is a positive and which side is a negative. Okay. All right. Okay, what is the function of diode? So this one, they will ask you, what is the function of diode? Diode essentially only allows currents to flow in one direction. This is used for, let's say, you know that our electric, at our house, okay, they provide us with the AC current, right? So not all the electrical appliance use the AC current. Some of it we use a direct current. So how we gonna change from AC to DC? Okay, so that is the function of the diode. Okay, so it allows to current flows in one direction from AC to DC. Because AC, alternating current, right? It can go back, and I already told you, right? It's like this. Okay. Okay, then the first cycle is like this. Then after it complete one cycle, then it go back, it just reverse. Okay, so means it's always change, right? So this one, for the diode, it will only allow one direction only. Okay, all right. So forward bias, I already explained just now, right? Okay, how diode is produced? I explained this one also already. Is by the joining the p-type with the n-type semiconductor to form a p-n junction. This is what I said just now. Why there's a story, right? The story why we come forward bias and reverse bias. Okay, so a diode is a device that allows currents to flow in one direction only. Okay, p-n junction. Okay, so when you combine the p-type and n-type of semiconductor, okay, there will be a p-n junction. Okay, this is the junction. Okay, is wide or narrow is depend, okay, on reverse bias or forward bias that occur there, right? Okay, so the boundary means the one that divide the p-type and the n-type regions, we call it as a junction. Okay, this one. Okay, it's just a boundary, to Okay, this is p-type, this is n-type. So the boundary, we call it as the p-n junction. Okay, so at the p-n junction, okay, the electrons from the n side. Okay, so this one at the p-n junction here, okay, here, this one is much clear. Okay, so the electron from the n side, so means from the this side, n-type, okay, you know that the n-type of semiconductor, they consist of many free electrons, right? So there we jump, okay, there we jump, okay, to the p side and to this side to recombine with the hole, means it used to fill the holes here. Okay, so this free electron, okay, that will move to the p p-type of semiconductor here, and it will combine with the hole, means it fill all the hole here. Okay, that one is depend on how many free electron does it got lah, right? But the electron will move to the p side and it combine with the holes. And this one, so the holes from the p side similarly, okay, move into the n side. Okay, so this one also we move to the into the n side where they combine with the electrons. Okay, so this one, okay, also move to the, so at the p-n junction, this one also move, this one also move. Okay, then they combine with electron, this one combine with the holes. Okay, so p-n-type is a positive charge and p-type is a negative charge now. Okay, why? Because the n-type now, say, remember I said just now, right? The n-type is a positive charge. Why? Because the holes, right, move to the n-type. So now they have more holes here. While the p-type, because the electron move to the holes here, right? So this one, the p-type, we have a negative charge because now the electron move to the p, okay, to the p side, okay. All right. So that is how. Then the depletion layer, right? The region around the junction is left with neither holes or no free electrons. Okay, so means the region around the junction, okay, around the junction is left with neither holes or no free electrons. So both of it don't have holes, don't have free electrons. So this layer has no charge carrier. It's a poor conductor of electricity. So this layer now, okay, there has no charge. Okay, because all of it already jump, this one jump here, this one jump here, right? So this layer has no charge carrier, is a poor conductor of electricity. So this natural region which has no charge carrier is called the depletion layer. Okay, so this one we call it as the p-n junction, right? This one is a p-n junction, the boundary. Okay, so when they have the holes and the electron there, so this part we call it as the depletion layer. Okay, so this one has no charge. Okay, so what is the function of the depletion layer? Okay, so any further movement of charge across the boundary in the depletion layer will be repelled by the charge in the layer. So let's say any movement, all right? So any movement, okay, of the charge across the boundary. Let's say that this one want to move here, this one want to move here, right? Okay, it will be repelled by the charge in the layer here. Okay, so mean that will not move. Okay, this one not go here anymore, this one not go here anymore. Okay, so then we move, okay, right, then until both of them have the no holes and no free electrons. Then after that they will form the junction, this one depletion layer. So this depletion layer, okay, stop the charge, okay, from moving to the p or p to n or n to p. Okay, next part, okay, this one it says content carriers should be semiconductor. Okay, semiconductor. So this one no charge, right? So the content carrier should semiconductor. Okay, content carriers should be semiconductor, and this one no, right? No charge because they have the same. Okay, junction voltage. So at the junction voltage here, okay, at the junction here, all right, the depletion layer here, the n-type regions form positive ions, okay, because the holes already move here, right? It's already moved here. So now at this part, they have the positive ions, okay, and the n-type move here, right? Remember just now I told that the p-type goes here, the holes, the electron goes here, the holes go here, right? It move, right? Okay, so because of that, right? So then with this one will become a negative charge, right? And this one will become a positive charge because of the movement just now, right? So at the junction, the n-type region form positive ion, p-type regions form negative ion. So a negative charge from a p-type side will repel any other electron that might cross the junction. So a negative charge from the p-type, so this is a negative charge, okay, it will repel any other electron that might cross the junction. So let's say this one want to go here, cannot because same charge, right? So same charge, it will repel. Okay, so this result is in a potential difference across central region known as the junction voltage. So this is the junction voltage. So means if the junction voltage is higher, means is very hard for the electron to fill the p junction. To p semiconductor here. Okay, so if the higher the voltage, the junction voltage, so it's hard for the negative, all right, the negative charge to move to the positive, to the holes. Okay, so this result in potential division across the central region known as the junction voltage. Okay, next part. Okay, at the junction. So at the junction, the positive ion form at the n-type region due to the lost electron, right? So just now we told that the n electron from the n go to the p and p go to n, right? So the positive ion will form at the n-type because they lost the electron, because the electron go here. Okay, then the positive ion repels holes from the p-type region on the left of the junction crossing the junction. Okay, so this positive ion, right? So this positive ion, okay, this positive ion repels the holes from the p-type region across the junction. Just now, the negative, right, repel the electron, okay, it repel the electron to fill the holes, right? Now the positive charge also repel the holes from fill the to fill the electron here. Okay, so at the junction, negative ion are formed at the p-type. Okay, so the negative ion is formed as the p-type due to an excess electron. So where does the excess of electron come? It comes from the negative, from the first part. Okay, that's it. The electron move to the p-type, and the p to the holes goes to the n-type, right? Okay, then we produce this one as a negative. Right. So the negative here, negative ion are formed at the p-type. Okay, so this negative ion will repel the electron. So it's the same as the story before. Okay, so let's say the negative ion want to fill the hole. Cannot. Why? Because they got the negative ion here. It will repel the negative electron. Alright. So the function of the junction voltage across the junction is to prevent charge carrier from drifting across the junction. Okay, what is the function? What is the using of the junction voltage? It's actually to prevent the charge carrier from drifting across the junction. So mean, let's say if they don't have the junction voltage, right? What will happen here? It will keep moving, right? This one positive move here, until no end, right? This one go here, this one go here. The hole go to electron go back to hole. Means there's no end of it. Okay, so if we do the junction, you have a junction, so it has the time that it will stop. Okay, so value of the junction voltage, okay, 0.6, while the germanium is 0.1. So I told you just now, right? I told you just now, the lowest the junction voltage, right, means it's easy for the electron or to the holes to move, right? To move from p-type or to n-type, and the n-type to p-type. Okay, so you can see obviously silicon has the high junction voltage, mean it's hard for the electron or the holes to move, right? After after they move one time, then they have to form the junction there. Okay, that to repel the electron for go back to the N type, and this one repel the holes for coming back, right? Okay, so there is a 0.1. So the condition for the electric current to across the PN junction, if it is connected to a dry cell, is the voltage applied across the diode must exceed the junction voltage. So what does it mean by this statement? So it said here, if you want the the diode to function, you need to have a high voltage than the junction voltage. But usually the battery is also I think the smallest one is 1.5, right? Volt. Okay, so I think there's no problem because the lowest voltage, right, for the dry cell is 1.5. Okay, you cannot find the one that have 0.6 unless you use a resistor lah. Sorry, a rheostat. Okay, all right. So uh, so here it says this one electron become negative ion, this one loses one electron because the electron already go here and the hole go here, right? So this one will be a barrier potential. Okay, so this one we keep the negative and the positive, okay, at the side. Okay, so they don't go around like that. Okay, so this is the pressure layer. Okay, I already explained this one. Okay. So the effect of this junction voltage, so I explained this now. Okay, it says to prevent the charge carrier from drifting across the junction, right? So if you don't have the junction voltage, then it will keep moving and go to P, go to N. Okay, so there is no end of it. So the junction voltage for the germanium and silicon are approximately 0.1 and 0.6. Okay? In order for the electric currents to flow through the diode, the voltage applied across the diode must be AC. This one no problem because the smallest voltage we have is 1.5, so it's okay. Okay, so forward bias. When a diode is forward biased, current can flow. Okay, so mean the resistance is low. Okay, when a diode is a reverse bias, the current cannot flow, the resistance is high. Okay, the current cannot flow because of the resistance is high. Why it high? Okay, this is movement. Okay, what happened during the forward bias? Oops, sorry. Okay, connection P-type semiconductor and N-type semiconductor to the battery. So forward bias, the positive terminal of the battery must connected to the positive terminal of the diode. Okay, positive to positive. So this is positive P, right? Positive, N is a negative. So positive must be connected to the positive. The negative should be connected to the negative. Okay, so that is the connection. All right, describe the movement. Right, describe the movement. How does the electron and the holes move? So the electron move across the junction to positive terminal, while hole move in the opposite direction to the negative terminal. Okay, so this one it says the positive, the negative. Okay, the electron move across the junction. Okay, so the electron here, it will move across the junction to the positive terminal. Okay, while holes move in the opposite direction, okay, to the negative terminal. So mean they move. Okay, this one go fill the hole, this one also fill the electron. Okay, okay, then compare the battery voltage with junction voltage. Okay, so battery voltage 1.5 means larger, means is enough lah. Okay, for the electron and the hole to move because it can overcome the uh, voltage, the junction voltage. Okay, so the thickness of depletion will become thin. Okay, so become thin. So when this become thin, it means it has the low junction voltage. So it's easy for the electron and the proton to move. Okay, then the resistance of the diode is low. Does the current flows? Yes, of course. All right. So this is because the charge carrier can move across the junction. So it can move across the junction. So the depletion layer is narrow. Okay, so means because they can move, right? So mean if the depletion layer here is lower, okay, it's narrow, means the junction voltage is lower. So the resistance also become low. All right, because it can the proton the holes can move to the electron can move, right? So they can move freely, right? So it means the depletion layer will become thin here, okay, and the current will flow because of the resistance is low. That what happened to the forward bias. Okay. All right. The next one is the reverse bias. Oh no, not yet. I think this is a reverse one. But they didn't change. This one is a reverse, right? Sorry, they just changed this one. If you got later at school, you just this one is a reverse, not the forward bias. Okay, they forgot to change the title. Yeah. So the positive terminal is connected to the N-type semiconductor. So you can see here for the forward bias, it should be positive is connected to the positive terminal, right? The P-type must connected to the positive terminal. But now the P-type is connected to the negative, alright? So the positive terminal is connected to the N-type semiconductor. That show is a reverse bias. Okay, then describe the movement of the electron and holes. So electron and holes are pulled away from the junction. No charge carrier across the junction. Okay, it's just simply like that. Like what I just like thinking is an analogy. Okay, so this is a positive charge, right? And this is a negative charge. So positive and negative is actually they will attract, right? They will attract with each other. So it will pull the P-type, this one, at this part, P-type here, okay, P-type region, it will pull it away like that. So the depletion layer here will become bigger because you pull it away, right? This one, because this one attract. Okay, is this like analogy? Okay, so the electron and holes are pulled away. Okay, so this one also same, positive and negative. So when positive goes to the negative, it's a different charge. Different charge attract each other. So this one also it will be pulled. It will be pulled. So this one also pull means the depletion layer will become wider. So at this part, you know already, if the wider the depletion layer means the junction voltage is larger. Okay. So when the junction voltage is larger, the holes and also the electron cannot freely move. Okay, cannot go N, cannot go to P, P cannot go to N because they have the high junction here. Okay, high junction voltage here. So they cannot overcome that voltage. So that's why okay the current will not flow. Okay, that one is actually as analogy for you to understand. Okay, so the positive and negative attract, so this one will be pulled here, and this one the negative, this one the different charge, it will pull. So this one pull, so they will form the white depletion layer. So white depletion layer means high junction voltage. So there is no way that the P can go to N and can go to P. Okay, then later I will see the forward bias one. Alright. Okay, so the thickness is thick, the resistance is high, the current cannot flow because of the resistance is high. Okay, so let's say for the one that we learned before, the forward bias, this one is reverse bias. Okay, back to this one. So positive goes to positive. What happened? They will repel, right? They will repel each other. For the reverse bias, it's attract. So that's why it pull the P-type away from the N-type. So now the depletion layer become thicker. Okay, this one positive goes to positive. Okay, same charge. Okay, same charge mean it will repel. So it will repel. It will push. It will push the P-type. Okay, and this one also will push because give a same charge, right? So when they push together each other, so what happened to the depletion layer here? It will become thin. So thin depletion layer means low junction voltage. So low junction voltage means the electron can move here and the proton can the hole can move to the electron can move to the hole. Okay, so the current can flow. Okay, so actually that's the analogy. This one remember change later I taught you. Yes, this is what I mean. Okay, the pulling of electron to the right, okay, and holes to the left causes the width of the depletion layer to increase. Okay, because this one attract, okay, so they will form the higher depletion. Okay, and this is the resistance also increase, then no current flows, okay, and the bulb will not light up. Okay, next part, okay. Communicate about the function of semiconductor diode and capacitor as a rectifier. Okay, we know that diode, it can change from AC to DC. Okay, now we have the diode. Okay, just now we learn how to make a diode. Okay, now we need, it's just like this. You want to make a cake, right? You want to make a cake, of course you need to have flour, egg, okay, sugar, okay. So now we already, we already have a cake. Okay, what is the function of the cake? Okay, what is the function of the cake? Okay, maybe you want to make it for the birthday party. Right? For the birthday party, or maybe for the graduation day. Right? You have a graduation day on this Saturday, right? Okay, so have a nice time. Okay. And then so that is the function. So now we already have the conductor. We know how to make a semiconductor N type and P type. Then we know that actually the N type P type can be used to form to produce the diode, right? Okay, now we already have the diode. So what is the function of diode? We want to use where? Okay. Okay, and how does it function? Okay, so let's see. So the uses of the semiconductor diode. This one I think on the textbook. Okay, so show a smartphone. Okay. However, the smartphone can only be charged with a direct current. Okay, like your phone. Okay, they only need the direct current. So how can you use the AC current? How you can change it to AC to DC? Okay, so you can use a diode. Okay, you can use a diode, but then how does the diode do that? So it's a lot of question. Okay, so in order to do that, they need to, okay, do the process of the rectification. To remember the process of the rectification is the process of converting, okay, an AC to DC. Okay, this one is very important, okay, because sometimes they will ask you what is the process to convert from AC to DC. So it's actually the name of the process is rectification. Or maybe sometimes the question asks, okay, what is the process, okay, that we need to add, okay, the doping element, okay, to the silicon or germanium. So that one is a doping process. So you need to know the name of the process. Okay, there are two types of the rectification circuit. Okay, there are two types of rectification, half wave and the full wave. Okay, half wave only use one diode, while for full wave is four diodes. Okay, remember, not two, no three. That no way two diode, three diode. No, only one and four. Okay, all right. So one diode. Now we see for the first one. To build a rectification circuit, okay, a halfway rectification circuit. So this is actually the diagram for the halfway rectifications, right? Rectification kit. So they have the diode here, okay. Of course, they need to have the resistor, right, to control the amount of the current that can flows, right? Okay, and this is CRO. You can see the graph, right? The shape of the graph. Okay. All right. So the first one, draw the input AC current signal. So AC, I think this one you already learned from 3, right? They have this positive and negative. Teacher, why it has the AC graph is like this? Okay. Remember when I told you just now, right? Okay. The currents for the AC can flow. Oh my God. The current can flow from positive to the negative, and then after that it change positive here pula, lepas tu negative here kan. So dia boleh berulang alik macam tu. Okay, so dia can be reverse back. So let's say for the first cycle, positive to negative. So this one is the positive to negative. See, they already labeled also. Positive to the negative, the first cycle. Okay, then after it reach here, it go back, alright? Then this is the below part, negative to positive. Okay, then after it reach here, okay, go back positive to negative. So this one, positive to negative. That's why they have upper part and also the below part because of the change of the direction. Okay, so then let's say we put the AC current, we connected it to the diode. Okay, so we connected it to the diode and we see the graph that being produced. Okay, so okay, I explain how do we get that. Okay, the first one, okay, remember, label the diode first. Okay, label like this. Okay, the first cycle, positive, negative. Okay. Oh my God. Okay. Alright, so positive to positive, forward bias, right? Positive to positive, forward bias. Forward bias, current flows or not? Yes, it will flow. Macam mengajar dalam kelas pula kan. I hoping like someone respond. Okay, never mind. So positive means forward bias, right? So the current can flow. So it flow. Okay. So forward bias, light will the bulb will light up means the current can flow. So see the current flows. Okay, we change the direction now, right? Because we change the direction. All right, because it can like change. Right, okay. Sabar. Okay, so the positive go here to the negative. Reverse bias. So reverse bias, does the bulb light up or not? No, it will not light up. So it will not light up means there is current, the current will not flow. Okay? Because happen reverse bias, right? So the current will not flow. So you can see the current is zero here. Okay, then it go back. Okay, never mind. It will not flow, right? Okay, never mind. I change again. Okay, so I go back from positive to negative. So positive, forward bias. Okay, so current can flow. Okay, then there's a current here. But then, okay, I change again. Negative, positive. So positive goes here, go to the negative. Reverse bias. Why reverse bias? The depression layer is very thick. That has the high junction voltage. So that one means the explanation, right? What happened actually in the diode. Okay. So it has a reverse bias. So that's the current will not flow. Okay. Then so on lah. All right. So that is a half wave. So you can see the graph also half. All right. Then the next part, yeah, this one I already explained. Okay. Diode convert the AC to DC. Okay. Now we form the full wave. This one is quite tricky. Why I say quite tricky? Because they have 4 diodes. And for each cycle, okay, they only use 2 diodes, 2 different diodes. Okay. All right. So first thing, what? Okay, let's see the AC current now. I just let it be like this. I will show you what does it mean. Yeah. Okay. Just want to show the draw the output scene. Okay. So what is the difference between the AC current just now? The output signal for the half wave and the full wave. What is the difference between the output signal for the half wave and the full wave? For the full wave, you can see the current will always flow, right? The current will always flow. Means there is no part, there is no the reverse bias part. There is no for the reverse bias part. Okay, why that is that? Okay, so I will show you later. Right? So see this one. What the thing you have to do first? Remember, negative, positive. Negative, positive. Maybe I should use another. Oh, never mind lah. Nanti I kena log in class point pula. Cikgu rasa kan, saya satu taman dengan saya ajar. Suara saya macam dah nak tak ada dah. Okay, let's see the first cycle. Alright. So you have to remember how does the diode being arranged. Okay. and which way does the current goes for each cycle. Okay, so let's say I put this one positive and negative. Remember, in order for the currents to flow, it has the positive meet with the positive diode, positive terminal diode. Okay, okay, let's start. The first one, okay, positive. Okay, go here. All right, at here. Okay, wait, which one you want to go? You have to produce the forward bias, no reverse bias here. Okay, so all right, if I that is mean if I go here in negative, right? So mean there will become reverse bias. So okay, I will go here. Okay, I go here, right? Don't go here. You ada jalan lain. Jangan ikut sini sebab this one is a negative. Teacher shortcut. Tak ada. Okay, so positive go here, positive. Okay, then go here, right? And go here. Okay, then go up. Okay. Teacher, we can use this one and this one also. Cannot. Why? If you use this one, then you go back to the positive terminal. That means your cycle is not complete. You have to go back to negative, right? So choose this one. Positive. Go here. Right? Okay, I show you again. Positive. Okay, here. Okay, so here or here. Okay, teacher said forward bias. So forward bias must be positive. Okay, positive here. Oh no, we cannot go here because this one is a reverse bias. Okay, go. Go. Okay, until here. Wait, both of it is positive lah. Kan? But teacher said if you go this way, you will go back to the positive. Okay, we cannot. We have to go back to the negative because you need to complete one cycle. So no. Bye-bye. Okay, I go this way. Alright, now I complete. So you see, first cycle. Alright, then next one. Okay, change the current. This one is positive, negative because AC, right? They can change. Okay, now you use go. Okay, now you see the blue one, right? We go here. Alright, we go here. Okay, now, okay, we have to go where? Of course, we need to use this one because this one is a negative. It must be positive. Okay, go here. Go here. Okay, go here. Alright, then this one, we go here. Don't go down because go down means you go back to the positive terminal again. Alright, the cycle is not complete. Okay, so go here. Okay, so the pair, you can see the pair, right? Which pair that we use? This one, okay, D1 and also D3. D2 pair with D4. Okay, so the current complete, so you can get the second one. Then it go back to positive again, okay, just like the first one I explained. You got the current here, okay, and so on. All right. So the important part is you have to know which part is a positive, which part is a negative. Okay, forward bias positive meet with the positive, right? This one already mentioned. I don't want to do it twice. Okay, this one also already tell you how does it, form. Okay. Okay, full wave rectification. All right, so this is a diagram. Okay. Also the same thing. Okay. Just this one is a complete one. They got the resistor and also the transformer to step down. You cannot put 240 volt into your phone. Okay. Okay. This is the another thing that is important. Why teacher said. Okay. You don't want, right? This is, that the current flows, right? At this time, no current. So do you want that your light, okay, sometimes switch on, sometimes switch off, sometimes switch on, sometimes switch off, okay, not, right? So you need one electrical parts, okay, to make it flow, okay, to make sure the current flows always, okay? So we use a capacitor, Okay, there's a lot of function of, not a lot actually, but not a lot. It's just like the term is same and it has the same meaning but use a different words. Like that. Okay, the function of the capacitor is to restore charge. Okay, to restore charge. Okay, or sometimes they call it I can't remember sometimes, sorry. To smooth the current, right? Okay, so how does the capacitor, right, help the current to make sure that it will flow all the time? Okay, so I just explained by using this one. So what does the capacitor do? So when the current at the maximum, okay, the capacitor will keep the charge inside it. It will restore the charge. Okay, but then at the moment here, there is no current, right? There is no charge flow. Okay, then what the capacitor will do, it will release the charge. Okay, then here it keep again. Then here it will release. Here it keep again. Here it will release. Okay, until the end. Okay, so that is the function of the capacitor. Okay, sometimes they put to restore a charge, to or to store a charge. Sometimes they say to smooth the current. Okay, both of it is the same. Okay, so half wave, full wave rectification produces direct current which is not smooth. Okay, so therefore a capacitor is used to smooth the current in the rectification circuit. So explain how a capacitor is used to smooth the current. Okay, so when current flows to the resistor R and capacitor, the capacitor is charged up and stores energy. But when there is no current pass through the resistor and the capacitor will discharge the charge and the energy from it used to produce a voltage, like I told you just now. Okay, here the capacitor store the charge, right? So when there is no charge flow here, it will discharge the charge that it keep. Okay, then here it keep again, then here it release again. Alright, so that is the function. So it can smooth the rectification, the full wave rectification. The half wave also can. Alright. Okay. All right. The sometimes the question, okay. Let's say if you didn't see the capacitor symbol. The capacitor is almost same as battery, right? But the difference is the capacitor that have the same length of the line here. You know, same length. Okay, so same length. All right. So this is capacitor. For battery must be one short, one long, right? So this is the symbol of the capacitor. If you see the symbol of capacitor, you must choose the graph that is already being smooth. Means it's already being like this. Okay. But if there is no capacitor, okay, there's no capacitor in the circuit, mean you need to know whether it's half wave or full wave. So this one is half wave. Okay, so you need to know the difference. You have to see whether there is no capacitor or there is a capacitor. Capacitor, that means the current is already smooth. No capacitor means the current is not more. Then maybe later they will ask you, right? That means later we'll ask you, okay, how to make the current become smooth? Then you can say you can use a capacitor. Okay, when they ask you where to put the capacitor, it has to be parallel with the resistor. All right. Okay. This is the video. Maybe I drink first. Okay. Okay, so this is the kit, right? But I don't know whether it's function or not. Is it that only? Okay, this is AC. Okay, they will just want to show this is AC current. Okay, so this is what? This is a half wave rectification. Okay. I'm sorry because I will let they have, but it's not function. Okay. As usual. Now we focus on light experiment. Others is later. So alright. The teacher said lah, right? This one is in Malay. So this says that this one is a forward bias. So at this part is the reverse bias. Okay. Okay. Next. This one you can, okay, this is the, you see 4 diode, right? So 4 diode means this one is a full wave rectification. The video show only that. Oh, wait, I see the graph first. I want to see the graph. It's supposed to be, no, maybe this one is not finished yet. It should be go up, right? Okay, tutorial. Okay, we finish about the semiconductor diode. Okay, all right. Do you have any question? How many of you here? 35. Do you have any questions? Please don't leave yet because I want to take a picture as a proof. Okay, as a proof. Okay, it's okay. I know this is off record. Okay, wait. Stop presenting. Okay. I will not record this one. Okay, so I know there's